So, first question here is 445 a term in the arithmetic sequence? So we could just, follow the pattern and keep going and see and find out, but that's very tedious. What's one way we can figure out if it is a term? Pardon me? Divided by 15. That would work if your first term was 15. So, and then all your numbers would be multiples of 15. But in this case, are they multiples of 15? No, because our first term is 5. So we can't just divide by 15 because that first term is 5. Could we pretend that it's a term? Yeah, could we? Let's pretend that it's a term, specifically our last term. We're going to treat it as our last term. Why would I want to do that? Yeah. So where they give us t of n, we're gonna say that's t of n, but we're gonna find n. Okay, so we can see we can find n for if that was a term. And what do we expect for n? N has to be what? Not a decimal. It has to be a natural number. N is an element of the natural numbers, right? So we expect it. What are natural numbers again? Whoop. Counting numbers. That's what my son does. Although once he gets to 12, he goes back to then he jumps to 15 and then 7 again. We're working on it. He's 2 though, okay? Give him some credit. Yeah, those are the counting numbers. Those are the first ones you learn. So we're gonna find. So what do we know? Let's list what we know. What do we know? First term is 5. We also know common difference is 15, and we're going to treat 445 as t of n, our last term. Remember, t of n, we can think of it as our last term. And we're going to solve for n. Here's our formula. It doesn't change. The handle. Oh, yeah, 1 second. Okay, so last term, 445. First term, 5. So the dividing by 15 method, you'd have to subtract off 5 first to see if it's a term, and then divide by 15, because that's essentially what we could do here if you're looking for n. But then you'd have to add 1. So that method's if you wanted to actually know what term number it was. Or we can just simplify this. Is it a term? Did you figure that out yet? 15n minus 10. Oops, where's my n? So then we add 10. It's been a while since you've done math, right? For some of you, it's been like a year. So 455 equals 15n. Does 15 go into 455? Oh, yeah, I added 10. Good. No, it's like 30.3 repeating. Right, so then, therefore, 445 is not a term. So we can't just divide by 15. I'm pretty sure if you divide 445 by 15, it goes in, doesn't it? Oh, it doesn't. But I could have gave you a number that when you divide, it does divide by 5, but then it's still not a term because our term, it's not multiples of 15. That works if it's a multiple of 15. If we start at the first term being 15, 0, 15, 30, right? Then that method works. But if your first term is not a multiple of the common difference, it's the same as your common difference, then you can't just divide by the common difference to see if it's a term. All right, these are like such popular, great questions. So what do I do? What happens if I give you the 8th term? So I'm going to draw some lines. 1, 2, 4, 5, 6, 7. So the 8th term is 32. 9, 10, 11, 12, 13, 14, and the 15th term is 74. I'm going to put a star. So here's the thing. Common difference. Do you know what it is? Nope. Do we know the first term? Nope. We're in trouble. They want us to find the first term and the common difference. So conveniently, those are what we're looking for. And there's 2 methods we can use to solve this. Okay? So I'll show you both methods. I probably should have, if I can move this all up. Yay! You can't do that, but I can. Wouldn't that be nice? Okay, so method 1 is treat term 8 as term 1. Oop, that's not as. Okay, so what we're going to do is we're going to pretend term 8 is actually term 1. So we're going to pretend that those terms ahead didn't exist right now. We're going to just treat that as term 1. And then what would term 15 actually be? Term what? So it's, yeah, 7. 15 minus 8. Term 7. And if you can count 2, 3, 4, 5, 6. Oh, no, not 7. Close. Term 8. So this is term 1, 2, 3, 4, 5, 6, 7, 8. Okay? So it's 7 more than it. 7 spaces. So if that's the case, then we're good. We can solve for our common difference. We can use that first formula, the one we're used to solve for our common difference. Because what would n be and what would t of n be? What would I use n and t of n as? So term 1 is 32. We would treat t of n usually stands. What's another thing we can call t of n? The last term. So in this case, it's 74, and n would be, like you said, n would be 8, right? Because these two go together. T of n, so t8 is 74, so n is sorry, yeah, term 8 is 74, so n is 8. They go together, right? These two should always coincide with the same ends. So we're going to treat that as a last term and now solve for our common difference. So let's do that. So t of n we said is 74. First term is 32 plus n, do we know what n is? 8 minus 1 times our common difference. Or 7Ds. Okay, so what would I do next? Minus 32 gives us 42. And then divide by 7. Which gives us 8. Okay. So once you know your common difference, you can get your first term. But I'm going to show you method 2 first, and then we'll do the first term last, okay? So that was method 1, is we treat term 8 as term 1, and then this becomes term 8, and find the common difference, okay? So we'll worry about finding the first term later. So method 2, we kind of set up our own equation. So we say, okay, well, to get from term 8 to term 15, so term 15 is equal to term 8 plus how many common differences? How many times are we going to add D? So we need to figure out how many jumps. And we count how many? 15 minus 7. This is where you can just subtract them, and that will be how many common differences you're adding. 1, 2, 3, 4, 5, 6, 7. So we can kind of come up with our own formula. Does that make sense? So term 15 is equal to term 8 plus 7 common differences. And then go from there. What was term 15? 74. What was term 8? 32. And do you see how these formulas here are the same? So different thought processes, but the same thing. We get the same formula. So we still subtract 32, divide by 7, and we still get D as 6. Okay? So it's really up to you which thought process you use. It really doesn't matter to me. I find students often like to make this the first term and then count. Some do it this way. It's up to you. Okay, there's two ways you can think about it. For getting the first term, there's the algebraic method, and then there's just the figuring it out. Okay? So you know your common difference, so you can work backwards. So the common difference was positive 6. What would I do to work backwards? Subtract 6. So I just subtract 6 each time, and so 32 minus 6 is what? 26. Subtract 6. 20. Then 14. 8. 2. Negative 4. And last, negative 10. So the term 1 is negative 10. And that's just finding it. I'm fine with that. I expect you to find D algebraically. Term 1, if you want to work backwards, that's fine. You can algebraically solve for it. So you would just use one of your terms, either term 8 of 32, or you can use term 15 of 74. Okay, so if I use term 8 as 32, we don't know what term 1 is. N would be, what would N be for using 32? 8, thank you. And then we know the common difference is now 6. Right? So we can again use that formula and plug in what we know. Sorry if this is small. I'm running out of room. And plug in, okay, last term, T of N is 32. Term 1 I'm looking for, plus 8 minus 1 times 6. So then I get 32 is equal to term 1 plus 7 times 6 is 42. Should have gave you more room for this one little area, hey? Sorry. Subtract 42, and we get negative 10. So you can solve for it algebraically. Do you have to? No. I'm okay once you show this algebraically, just working it backwards if you want. Okay? You could have also used 74 and then 15. N is 15, and that would give you negative 10 as well. Okay? All right. So those are very popular questions where you don't know your first term, you don't know common difference, you just know random terms. That's why we have a little bit more time for homework today. Okay, 2 more. How many multiples of 3 are there between 12 and 99 inclusively? First off, you need to know what inclusive means. Oops. What is inclusive? In only? Maybe? It is the right word. What's another word with, like, another root of inclusively? Another word like inclusive. Like if you're inclusive, you are including. So, including 12 and 99. If you're inclusive, you're including. Exclusively, you're excluding. including 12 and, so your first term then would be, your first multiple between 12 and 99 is 12. What would be the next multiple of 3? 15. Careful. So although you're talking about multiples of 3, do the multiples of 3, are they geometric, multiplying by 3, or are they arithmetic? They're arithmetic, because we're adding 3 each time, and then those numbers are multiples of 3. Okay, and so forth. Is 99 a multiple of 3? Yes, so it's our last term. I could have also said, like, how many multiples of 3 are between 2 and, or say 10 and, I'll just make it simple, 64. So what would your first term be? Would it be, is 10 a multiple of 3? No, so your first term would actually be 12 between 10 and 64. So 10, so 12, and 15, and 18. What would your last term be? Is 64 a multiple of 3? No, what would be the last multiple of 3 then? 63. Okay, so just because I say between 10 and 64, multiples of 3 have to be multiples of 3. 10 is not a multiple of 3. So the number, if we're looking for the number of multiples of 3 between two numbers, you have to figure out your first multiple and the last multiple between those two numbers to figure out your first term and your last term. I made it simple in this example, and I made those multiples of 3. But they don't have to be. It could be any numbers. And you have to find the first one and the last one between those two numbers, okay? All right, so with that, tell me what to do next. Let's start listing what we know. What do we know? T n is 99, our last term. Okay, what else? First term is 12, and what else do we know? Common difference is, my dear, 3. What are we looking for if I'm asking how many? N. How many terms or how many multiples? That's n. Okay, term 1 plus n minus 1 times d is equal to t of n. So let's sub it in. T of n, you said, is 99 equals 12 plus n minus 1 times 3. Let me get 3n plus 9, 12 minus 3. So always want to move the constant first before we divide. Subtract 9. Right, when we isolate a variable, you do opposite of BEDMAS. So we have to subtract the 9 first. And then we divide by 3. Gives you 30 multiples. Whoa, that was funny. 30 multiples. Okay. All right. One more very, very good question. I think there's a question like this in your homework that's starred. It's technically AP, but I highly recommend you do that. Like, there's not really any AP questions. There's some challenging questions. Questions like these tend to show up on your quizzes and unit exams. Okay? Both of these. So, the terms 2 of x plus 3, and then 3x plus 1 and 8x plus 3 are consecutive terms of arithmetic sequence. So they're telling you that they're arithmetic and they're consecutive. What does consecutive mean? One after the other. So term 1, term 2, and term 3. They're not like term 1, term 7, term 10. Find the value of x and the value of the 3 terms. Okay, I'm probably going to lead you on how to solve this one, because students often what they'll try and do is like sub it into like, well, okay, term 1 is 2x plus 3. I can make term 2, which is your, right, n is 2, then t of n 3x plus 1, but still you don't know your common difference, right? So what is it? So what you want to do in order to solve for x is we can relate these three terms somehow. Okay? So how is term 1 and 2 related to 2 and 3? What do they share? They share the same common difference. Okay? So what I mean by that is, would you agree that the common difference is equal to term 1 minus term 2 minus term 1, but it's also equal to term 3 minus term 2? In order to get the common difference, if you subtract consecutive terms, then you'll get your common difference. So that's how we're going to relate them. We're going to relate them with their common differences. Okay? So term 2 minus term 1 is equal to term 3 minus term 2. That's how we're going to set them up, because that's equal to their common differences, and their common differences are the same. Why? Because they tell me it's arithmetic. So they have the same common difference. Okay, now what you need to be very careful is with your subtraction of polynomials. So I recommend brackets here. So when I sub in term 2, I'm going to put it in brackets. Sub in term 1, put it in brackets. So what's term 2? 3x plus 1 minus 2x plus 3. And then that's equal to term 3 minus term 2. So 8x plus 3 minus 3x plus 1. So back in 10C, when you subtracted polynomials, all depends on your teacher. Most of your teachers probably changed it to addition by switching the signs, right? No? It depends on your teacher. You had me, so yes, that's what we did, but I don't know who you had for 10C. So what we can do is, I want to make this into addition because then I'm less likely to make a mistake. And so I'm going to switch the signs of whatever we're subtracting. So negative 2x minus 3. Technically, you can just get rid of your brackets, but I'll leave them there. So I'm going to make this addition by switching the signs. Or if you feel confident in your subtracting abilities, you're welcome to do that. You just have to be careful, especially if one of these was a negative, because when you subtract negative, it changes to a positive, right? It's like adding a positive. So that's what you have to be careful. Okay, so 3x, collecting like terms, 3x plus negative 2x is 1x. 1 plus negative 3, 1 minus 3, minus 2 equals, okay, on this side, how many x's? 5. And 3 plus negative 1 is 2. Okay, how do I solve for x now? Isolate the variables. So we want all the variables on one side and the constants on the other. So I like to keep x positive, so I'm going to move the x over into the 5x. So if we always want to do the opposite. If you're moving it, if it's a plus x, we want to subtract x. Which is 4x plus 2, and then we're going to move the 2 over, so subtract 2. And then divide by 4, which gives us negative 1. Okay, so that's x. Now you have to be very careful. You can get very excited. If I'm just asking for x, then you're done. But then I can ask so many things now. Now that you know x, I can ask for any term. I can ask for, what is the common difference? What is the first term, right? So in this, it says find the value of the three terms. So term 1, now we actually have to figure out the actual value of it, now that we know x. Term 1 was equal to 2x plus 3. And now, guess what we know? X. So term 1 is 2 times negative 1 plus 3, or some subbing in my x value that we found into term 1. And that's equal to 1. Term 2, 3x plus 1. 3 times negative 1 plus 1 is negative 2. So now we know our common difference is negative 3. We expect negative 5 as our last term. If you want to sub it into to make sure, into the 8x plus 3, you can. So 8 times negative 1 plus 3 is negative 5, which makes sense because it's arithmetic. Okay, we're done. Did your head hurt? Are you okay? Shaky? All right, so that's it for today's lesson. I'm going to write the homework questions down. We have more time than yesterday. Oh, there's no start questions. Good. Okay, good. So, page 16 to 20, numbers 6 to 13, 14 ABC, 16, 17, and 23.